In our video today, we're going to consider how to deal with indices, how to deal with questions that involve applying the rules of indices, and we'll also look at what the rules of indices are. The first thing we want to ask ourselves is, what does the word indices mean? Well, the word indices is just a plural for the word index, and the index means the power to which a number is raised or to which a letter is raised. For example, in a raised to the power of 5, the 5 is the index or power to which a is raised. So this 5 here is the index of a in this particular situation, and this a is referred to as the base. So a is the base and 5 is the power or the index. And when you say indices, it just means the plural of the word index. Now, before working with indices, when dealing with mathematical questions, there's some rules that have to be observed, and we've put together a few of those rules here. The first one is a raised to the power m multiplied by a raised to the power n is equal to a raised to the power m plus n. So when dealing with indices, when you have the same base and then it's raised to a power and you're multiplying both of them together, you just write the base again, the base a, and then you add the powers as we did here. The second rule has to do with division. You have a raised to the power m divided by a raised to the power n. Here, when it's division of indices, when they have the same base, you just subtract the second one from the first one. The second one here is n. You subtract it from m. Here you have a raised to the power m minus n. So for example, if we have to do with numbers, and you have here we have 5 raised to the power 4 divided by 5 raised to the power 2. They have the same base 5, so what we just do is we write the 5 again, and then we have 4 minus 2, and that's 5 raised to the power 2, and that's going to be 25. In the first law, we skipped the example there. There we have 5 raised to the power 3 multiplied by 5 raised to the power 7. So 5, same base, so you just add 7 plus 3, because here is a multiplication, so we just add the indices, the index of 3 here and the index of 7 here. We add both of them together and we have 5 raised to the power 10. Now in the third rule, we have a raised to the power m in bracket all raised to the power of n. So here you have a raised to the power m raised to the power of n. Here what you do is you multiply the two powers, because here you have an m which a is raised to, and then a raised to the power m is raised to the power of n again. So there you have a raised to the power m times n. Note that this is different from the first one. The first one you have a raised to the power m multiplied by a raised to the power n. But here you have a raised to the power m all raised to the power of n. So in our example, we have 5 raised to the power 3 in bracket all raised to the power of 7. So that's going to be 5 raised to the power 7 times 3. That's 5 raised to the power 21. Now the fourth rule, we have ab in bracket raised to the power of n. So here what you do is you take the a, you raise it to the power of n, and then you multiply it with the b raised to the power of n. So we have a raised to the power n multiplied by b raised to the power n. So let's see here an example with numbers. Here we have 5 multiplying 3 in bracket all raised to the power of 2. So that's going to be 5, take the 5, you raise it to the power of 2, have 5 raised to the power 2 here, and then you multiply it with 3 raised to the power of 2 as well. So then you have 5 squared is going to be 25, 3 squared is going to be 9. So you have 25 times 9, that's 225. Now if you decided to do this straight away from here, 5 multiplying 3 is 15. 15 squared is going to be 225. So either way you still get your answer, but that's just the rule when using the rule of indices. Now in the fifth one, we have a divided by b raised to the power of n. So what we do here is you just raise a to the power of n divided by b raised to the power of n. Very easy. So let's look at an example here. We have 6 over 3 in bracket raised to the power of 2. So that's going to be 6 raised to the power of 2 divided by 3 raised to the power of 2. So that's going to be 36 over 9. That's going to be 4. And you see here, if we did it straight away, 6 divided by 3 is going to be 2. And 2 squared is going to be 4 as well. Now the sixth rule says that a raised to the power of 0 is 1. Well, anything raised to the power of 0 is 1. So 1 million raised to the power of 0 is also going to be 1. And here we're going to try to prove this using what we have here. If you have a raised to the power 1 divided by a raised to the power 1, we know that's going to be 1. But using the law of indices, a raised to the power 1 divided by a raised to the power of 1, since they have the same base, a and a, so we have a, and since it's division, we subtract the powers. So we have 1 minus 1. 1 minus 1 is 0, so a raised to the power 0. So since we know that a divided by a is 1, a raised to the power 0 must be 1. Now the seventh rule, we have a raised to the power minus n is going to be 1 over a raised to the power n. So if you have a raised to the power minus 5, it's going to be 1 over a raised to the power 5. So we have this example here, 5 raised to the power minus 2. So that's going to be 1 over 5 raised to the power 2. That's 1 over 25. And then the last rule we have here says if you have a raised to the power 1 over n, it's going to be the nth root of a. So in this example here, we have 125 raised to the power of 1 over 3. So that's going to be the third root of 125. And 125 is 5 times 5 times 5. So the third root just means a number that you multiply 3 times to give you 125. So that's 5.